So hi guys, welcome to day 5 of the Kaggle machine learning course. So today exercise is of lists. So we have a notebook. You should have got a link. Here is the link. You can go in the exercise sheet by clicking on this link. But before doing the exercise, I would advise you to read this document on list. It's going to be very helpful. So I have already solved this exercise. So let us have a look on it, and we will discuss the concept and we will discuss the logic on this exercise notebook. So first, as always, we need to run the first code cell. You can run it from here, or you have a shortcut key on Windows, Shift and Enter. So first exercise is complete the function below according to its docstring. So what it is saying that return the second element of a list of a given list. If a list has no second element, return none. So we have a list. Suppose we have a list. Name fruits, and we have fruits like apple. We have to write in string because it's a string. Apple, orange, banana, and watermelon. Okay, we have this list, and first we need to check return the second element of a list. If a list have no second element, we have to return none. So first we have to check length of a list. So if we will do len l less than 2, so what is length function? Length will give you how many length you have in a list. So if you do len of fruits, you will get 1 2 3 1 2 3 4. You should get 4. Okay, you got 4. So here we are checking if length of L is less than 2, we will return none. If it is more than 2, else we will return L index 1. So you should also know the index. So apple is in the index number 0, orange is in the index number 1, uh, banana is on a index number 2, and watermelon is on a index number 3. So if you will like calculate index and you will call 1, I think you should get orange. Index is not defined. Okay, so we need to define an index, but it should work. Okay, so the mistake I have done is call index like this, open a bracket. Okay, sorry, fruits dot index is not in a list. We have to call a list 1. Okay, sorry, we have to, it will give me index, it will not give me index number. done wrong. To find orange, it will give me 1. It's in index number 1. Okay. And if I will find banana, it will give me index number 2. 0, 1, 2. Okay. So that's how index work. So do mistake, read and learn, and try again. That's the way you learn how to code. Let's move to the second question. You are analyzing sports team. Member of each team are stored in a list. The coach is in the first name in a list. The captain is in the second name in a list, and other players are listed after that. These lists are stored in another list which start with the best team and proceeds through the list to the worst team last. Okay. Compete the function below to select captain of the first team. Okay. So it's a list within a list. Let me see if we have some example. List within a list. I think we have to make list within a list. So example equals to 1 2 3 sorry 1 2 3 4. It's a list 1. List 2 will be comma 7 8 comma. So we have made a list. So we have to find a second player which is captain from the worst. Okay, so the worst list is the last list. So somehow we need to get this list. Okay, so how we can get the last one? I think we can get x minus 1. If we will do minus 1, let's see what we get. We get the last sheet. See, 7265. 7265. Okay, so if we will do minus 1, we will get a last item in the list. Example, if you will do fruits and you will call a list minus 1, you will get this one, a watermelon. So in the same way, if we will do minus 1, we will get this. But we don't want the full list, we want this 2. No, second player. We need the second player, which is the captain. Like, so if we can store it into another variable, a is equals to x. So we have a list in a, and we need to get, okay, if we will do a and we will call 1 index 1, get this second one. Let's see what we get. Let's store it in b is equals to this, and let's call b. We got right. So we can do this in this way. So I have done the same thing here. A is equals to teams minus 1. Here is the team, list of team minus 1. We will get a last list, and from the last list we want a second item. So we will do b is equals to a1. So we will get a second item from that list. and we are going to return B. If we will run this, it's solved. Okay. Question number 3. Okay. The next iteration of Mario Kart will feature an extra infuriating new item, the purple shell. When used, it wraps the last place racer into first place and the first place racer into last place. Complete the function below to implement purple shell effect. Okay, so you have a list, and suppose this is a list. Okay, so this is a list. So you need to change Mario into Luigi and Luigi into Mario. Like it will go here and this will go here. So we need to swap this. So one easy way of doing is like what we can do is R 0 comma R uh, -1, okay, is equals to R0 will change into R -1. R0 will change into R -1 and R1 should change R0. -1 should change R0. Okay. So what it should do is R0, that is this one, will change into R1. It will swap. R -1 will swap into this one. Okay. Let's see if it work or not. Let's store it into A, variable A. Let's see it has executed. Okay, Luigi and Mario. Okay, so it have changed. Hmm. Okay, you don't have to like do this. Can call R and we got a list. We got a change list. Okay, we have changed this into this into this, and if we call R, we have solved this problem. So we have done the same thing here. The racer index number 0, racer index number -1, first and the last one, and we have changed it into last into first one. So we are done with this. So this is how you need to find a logic, and you need to do a rough work. You need to break your code to make it simple. Okay, so here we have to guess like the length. So first one is easy. The length will be 3, 0, sorry, 1, 2, 3, length is 3. What will be the length of B? 1, because it's a list 1, and it's a 2, it will be 2. 3 will be 0, and again it will be 2 because 1 list, second list 2. Okay, so you need to know this, how this works. Like it's 3, 2, 0. Okay, you can read this one if you have some doubt. Okay, fifth one. Fashionably late arrival name. Given an order list of arrivals to the party and name, return whether the guest with that name was fashionably late. Okay. So what is fashionably late? First we need to know that. We are using list to record people who attended our party, what order they arrived in. For example, the following list represents a party with 7 guests in which Leela showed up first and Ford was last to arrive. Okay, it's a list uh, in the order they have arrived into the party. Like this is the first, second, third, fourth, fifth, sixth, seventh. Guest is considered fashionably late if they arrive after at least half of the party guest. Okay. However, they must not be the very last guest that's taking it too far. Okay, the guest who is last is taking it too far. Uh, he is not fashionably late. He is taking it too far. We should not include the last guest. In the above example, Mona and Gibret are the only guests who were fashionably late. So if we will like 1, 2, 3, 4, 5, 6, 7, and if we divide it by 2, that is 3.5. It's 1, 2, 3.5. You can Mona and Gibret are fashionably late. Complete the function below which take a list of party attendees as well as person and tell us whether that person is fashionably late. Okay, so uh, we have make a variable that is arrivals dot index name. So we will find the index of a name. So okay, we have an list, uh, arrival list and name. Okay, so suppose arrival is the list dot index name. So we will get an index number. Okay, we got an index number. So the return. So if order is greater than equals to uh, like the average number of people. Okay, so order, if the order this order is greater than the average number of people and order is not equals to the arrival minus 1, that the last one, the return will be true. The return will be true, which means that he is fashionably late. Okay, so what I mean to say is here we find a number and like not there was not there was 10 guests and we got a name of like guest number 8, so it will give me 8, index number 8 according to list. And if 8 is greater than length of arrival by 2, means 10 minus 2 5, 8 is greater than 5, yes, and order is not equals to length arrival minus 1, that is the last item in the list or last guest in the list, that is the 10th one. It is not equals to 10, so yes, it means it is fashionably late. We run a code, the code is executed. Okay, and solution is also here, if you can see this. So we are done with the list, but we have two exercise. Second one is loops and list comprehension. So again, before starting the exercise, you should you should read this document. It is really important, but I have already solved it. So see we'll see the logic, how to do it. First we have to run the first uh, code cell. It is really important. Not then only rest of the cell will execute. the code is executed. So have you ever felt debugging involved a bit of luck? The following program has a bug. Try to identify the bug and fix it. Okay, so this one have some bug. We need to identify a bug and fix it. So now return whether the given list of number is lucky. A lucky list contain at least one number divisible by 7. So we have done this. Let us see. Uh, Return any n modulus 7 equals to 0 for n in nums. So what it is doing is it is like iterating all the values, and it is checking if n modulus 7 equals to 0. Okay, like so for this list the comprehension, if you have some idea about SQL, it will be really simple to understand this, because in list comprehension, first we do a mathematical part, like the where clause, like it start, like in SQL it start from select, then where. Okay, so first we have to select, we have to do the mathematical thing, n modulus 7 equals to 0. Then we have to start a loop for like n in nums. So here you will have a list, nums is a list, and it will iterate your list, and it will check if n modulus 7 equals to 0. If it is true, it will return true. If it is false, it will return false. Okay, so we have an explanation here. Remember that return clause a function to exit immediately. So our original implementation always ran for just one iteration. We can only return false. If we looked at every element in the list and confirm that none of the items are lucky, though we can return easily, the answer is true. Okay, so the first, this one which have some error, it is explaining define as lucky number equals to nums, like nums. For nums in nums, if num modulus 7 equals to 0, return true. We have exhausted the list without finding a lucky number. Okay, we have already exhausted a list without finding lucky number, return false. Here's a one-line version using a list comprehension with Python. Any function you can read about what it does by calling help any. Okay, so if you will like you need help, you can call help function. Help know what this function do any. So help on built-in function in any module built-in. Return true if boolean x is true for any x in the iterable. If the iterable is empty, return false. Okay, if like it is true, if it is true, it will return true. If it is false, it will return empty. Okay, so that was a difficult one. Look at the Python expression below. What do you think we will get when we run it? Okay, so I want you to guess that what will it return when it runs? Let's check. I think it will return nothing. It's an error. Okay. So what is saying here is return a list with same length as L where the value at index I is true if Li is greater than fresh and false otherwise. Okay. Element greater than 1, 2, 3, 4. Okay. So we have to return true if x is greater than fresh, else false for x in L. So as I have said, first you will do the mathematical part or the condition part, then you will run your loop. Like I have run a loop for x in L, okay, and we will check if x is greater than thresh, then it is true, then it is true, and or else it is false. Complete a body function below according to this docstring. So given a list of meals served over some period of time, return true if the same meals have been served in 2 days in a row. Okay, so so if a meal is served 2 days in a row, we have to return true or false, else we will return false. Okay, so we have to run a loop for I in range length of meal minus 1. Okay, so we got a length of meal minus 1. Suppose length of meal minus 1 is 10 minus 1 9. So length of 9, it will start from number 0 0 1 2 3 4 5 6 7 8 9, and range, we'll find a range if meal of meal I. So like meal C, the first meal is equals to the second meal, return true else false. So it will run one more time. The first uh, index number 1 is equals to index number 2, return true or false, else false. Okay, so it will check the all the item in the list, and if the item are not repeated, it will give true value, else it will give false value. So you can read this explanation here. Number 4, play slot machine. Okay, so it's a game, a slot machine game, and let's read the rule. Run the slot machine and run times and return the average net profit per run. Okay. Example call. Note that return value is non-deterministic. So non-deterministic means the return value is not fixed. It can change. Means the result can be anything when you play this game. Estimate average slot payout 1 minus 1 estimate slot this. By the way, did mention that each play cost $1. So each play will cost $1. So they are saying, don't worry, we will send you a bill later. On average, how much money can you expect to gain or lose every time you play the machine? Okay, how much money you can lose or win? Casino keeps it a secret. You can estimate the average value of each pool during a technique called Monte Carlo method, or it is also called Monte Carlo simulation. to estimate average outcome. We simulate the scenario to many times and return average result. Complete the following function to calculate the average value per day in a slot machine. Okay, so let's start. So we have first gave winning equals to 0 because when we started a game, the first game, we have not won anything, like we have started with 0 winning, and we will start a for loop for x in range and run. We will find a number of runs and we will get a range of runs, and winning equals to winning plus play slot machine. Okay, so winning equals to 0 plus play slot machine, this one. This value will not be fixed, it will change every time you run this. It will change because the game will change and the value will also change. So we need to add this, and winning equals to winning minus n run. So winning equals to winning minus n run. Why n run? Because for each game we need to pay $1. I have said this is estimated average slot payout minus 1. Now they have said it here. We mentioned that each play cost $1, so each play will cost $1. So that's why we have done here n runs, because it just count 1 2 3 4 5 7 8. So 1 for 1 game, 2 for 2 game, 3 for 3 game, 1000 for 1000 games. So it will do that, and we will now return winning minus n run. So we will get average winning, and if we will like call this function estimate average slot payout, this one, and we will give n run. So we need to check it with large value. Let's see if we will start with small value. Okay, it's not defined, so we need to run it. Okay, I think it should work. So if we will start with a small value, it will not work. We should start with a big value. The number of runs should be big. It might take some time to run because it's a very large number. It will also depend on your computer, like which computer you have. It's taking too much time. Let me cancel this and use a bit small number. Try this. Okay, what our result, that is a free slot payout is 0.24. Take the solution, take this, and it is saying if your answer is way higher than 0.025, then maybe you forgot to account for $1 cost per day. I think we got a right answer, and we are done with the exercise of Kaggle machine learning course for day 5. So if you like this video and you like my content, please like and subscribe to my channel, and again I will post the video for day 5 at the same time tomorrow. So thank you for sticking with me, and I think at the end of the day 30 we will have a really good the concept of machine learning. So thank you guys, see you.